Imagine a world where you never have to charge your phone again. Sounds like a dream, right? But this dream is on the cusp of becoming a reality. A Chinese startup, Betavolt, has introduced an innovative battery with a bold claim. It can generate electricity continuously for 50 years without the need for charging or maintenance. This isn't your typical battery, though. It's nuclear in nature, yet surprisingly compact, smaller than a coin. Betavolt managed to incorporate 63 isotopes into this tiny module, marking the world's first realization of the miniaturization of atomic energy. This next-generation battery is currently being tested and is poised to revolutionize power supply across multiple scenarios, from aerospace to artificial intelligence, medical equipment to micro-robots. So how did we get here? To answer that, we need to go back in time. The battery story begins in the 1800s with Italian physicist Alessandro Volta. In a world where electricity was a fascinating mystery, Volta's creation, known as the voltaic pile, was a game changer. This was the first true battery, a contraption that could generate a steady stream of electricity. It was composed of alternating discs of zinc and copper separated by brine-soaked cloth or cardboard, a simple yet revolutionary design. As the 19th century progressed, so did the evolution of the battery. The rechargeable lead-acid battery was introduced in the 1850s. This invention by French physicist Gaston Plante was a significant milestone. Unlike Volta's battery, this one could be recharged and used repeatedly, bringing about a new era of convenience and utility. Fast forward to the mid-20th century and we find ourselves in the era of the alkaline battery. This was a major leap forward in battery technology. Invented by Canadian engineer Louis Urey in the 1950s, the alkaline battery boasted a longer life and better energy storage than its predecessors. It was also safer, with a significantly reduced risk of leakage. These innovations were not just about powering devices, they were about reshaping our world. From the telegraph to the electric car, from the humble flashlight to the life-saving pacemaker, batteries made it all possible. They allowed us to break free from the constraints of wired electricity, enabling the portability and mobility we now take for granted. It's easy to overlook the importance of these little powerhouses. Yet they're in almost everything we use: our phones, laptops, watches, and even our cars. They're the silent partners that keep our modern tech-driven world running smoothly. But the battery story doesn't end here. As we continue to innovate and push the boundaries of what's possible, the humble battery continues to evolve, powering our future in ways we can only imagine. These advancements paved the way for the portable power we rely on today. Fast forward to the 1940s and we have the birth of the mobile phone. This revolutionary invention, used first by the Swedish police department, was powered by a battery that was none other than a car battery. Can you imagine that? The phone was hooked directly to the battery, and after a mere 6 calls, it was lights out. This was a time when mobile phones were not so mobile. They were bulky, heavy, and practically tethered to your vehicle due to the colossal amount of battery power they required. The small, efficient batteries we're familiar with today were barely a twinkle in an inventor's eye. Take Ericsson's mobile phone in the 1950s, for instance. This beast weighed in at a staggering 80 pounds. That's about the weight of an average 12-year-old child or a medium-sized dog. It's almost comedic to think of lugging around such a device today. As we approached the late 1960s, mobile phones began to evolve. They were no longer confined to a single vehicle or location. They could operate within a specific calling area, but the battery life was still a significant concern. Over the decades, we've seen a remarkable transformation in the size and efficiency of mobile phone batteries. The clunky car batteries gave way to smaller, more manageable power sources, and the phones themselves became more compact and lightweight. In tandem with these changes, the battery life also improved dramatically. Today, we don't think twice about making a call or sending a text, streaming a video, or even navigating with GPS. All these activities, which would have drained the batteries of yesteryears, are now taken for granted thanks to the leaps and bounds in battery technology. These developments marked a significant step forward in portable power, but the quest for a longer-lasting battery was far from over. And now we arrive at the present day where the dream of a battery that never needs charging is becoming a reality. Enter Betavolt, a Beijing-based startup which has unveiled an innovative nuclear battery that promises to produce electricity continuously for 50 years without requiring any charging or maintenance. Despite its nuclear moniker, the battery is impressively compact, with Betavolt managing to pack 63 isotopes into a module smaller than a coin. This isn't just a battery, it's a revolution in miniaturization of atomic energy. Currently under testing, this next-gen power source is being primed for mass production, ready to power everything from phones and drones to medical equipment and micro-robots. The battery itself is a marvel of engineering. Measuring just 15 by 15 by 5 millimeters, it's composed of wafer-thin layers of nuclear isotopes and diamond semiconductors. While its current power output stands at 100 microwatts at 3 volts, Betavolt has set its sights on a 1-watt power output by 2025. But how does it work? The operation of this battery involves harnessing the energy generated from decaying isotopes, a concept explored as early as the 20th century, and converting it into electricity. The genius of this design lies in its resilience. It's resistant to fire and explosions due to sudden force, and can function in temperatures ranging from -60 degrees Celsius to 120 degrees Celsius. Moreover, Betavolt emphasizes that the radiation emitted from the battery poses no threat to the human body, making it suitable for use in medical devices like pacemakers. And when it comes to environmental impact, Betavolt assures that after the isotopes decay, they transform into a stable, non-radioactive isotope of copper, posing no threat to the environment. This is more than just a battery. It's a symbol of the technological leaps we are making, pushing the boundaries of what's possible. As Betavolt concludes testing and secures necessary clearances, we stand on the cusp of a seismic shift in power solutions. With such advancements, we are on the brink of a future where charging your phone could become a thing of the past. So what does all this mean for you and me? Well, imagine a world where charging your phone becomes a thing of the past. A world where our devices are powered by compact, long-lasting batteries, revolutionizing not just our personal tech, but industries such as aerospace, medicine, and robotics. That's the promise of Betavolt's nuclear battery. A battery that can last 50 years without charging or maintenance might seem like science fiction, but it's becoming a reality. This innovative technology taps into the energy generated from decaying isotopes, miniaturized into a module smaller than a coin. And despite its nuclear nature, Betavolt assures the radiation emitted poses no threat to the human body, making it a potential game changer for medical devices like pacemakers. In essence, this is a leap towards a future where power limitations become irrelevant, opening up limitless possibilities for technological advancements. In the world of batteries, it seems the best is yet to come. Stay tuned to witness the future of power.